Hey everyone, it's Christian the P4 working with Dr. Matulowicz these 5 weeks for my APPE, and here is your video on powder packet calculations. So a few important concepts before I go into the two calculations I'm going to go over. Important concept number 1, a complete powder packet contains at least two components, the active ingredient, or the AI, and the diluent, also called the excipient or filler. So those are the two required components, and you have an optional component, or the coloring of the dye. So a visual representation. Here's your powder packet. It's going to contain the active ingredient. It's a powder, and then the diluent to fill the space, which is the excipient, also called the excipient or the filler. And usually you want this so the tablets feel, or the powder packets feel full, since giving a patient empty or inadequately filled powder packets can feel odd and suspicious. So it's for pharmaceutical elegance usually, to give them a full feeling, a powder packet that feels full. So usually for solid dosage forms, concept number 2, you're going to make extra to account for loss. So unless you're otherwise told, remember to calculate for 10% extra packets to account for powder packets being incorrectly made or powder being lost. An important formula, it's important, and I'm highlighting it in red because it's important, to use for these calculations is amount of AI per tablet divided by the average weight per tablet equals the amount of AI for the total prescription divided by the amount of crushed powder for the total prescription. So basically, the formula works out. It looks like part divided by part equals whole divided by whole. So part of the AI divided by, so the AI in one part, or the weight of one AI, or the tablet divided by the tablet in one part, or the weight of one tablet, equals the whole AI, or the whole mass of the AI for the whole prescription, divided by the whole weight of the crushed powder, since you're crushing the tablet to give you your crushed powder. So basically, the weight of a single active ingredient in a single powder packet, divided by the weight of a single tablet, equals the weight of all the AI in the whole all the AI needed to complete the prescription, divided by the weight of the whole crushed tablet to give you the crushed powder. Crushed. And usually you're going to solve for the amount of crushed powder for the total RX. Concept number 4, partial tablets and powder packets cannot be dispensed, so we're going to round up if we calculate a partial tablet or partial powder packet. So you can't give a patient, so here's a whole powder packet, you can't give a patient, if you calculate it, you can't give a patient 0.4 of a powder packet. Or if you calculate a tablet, you can't give a patient 0.4 of a tablet. That just seems odd and suspicious and not pharmaceutically elegant. So if you ever calculate a partial powder packet or tablet, round up to give you a whole powder packet or tablet. And number 5, in real life, and if you're told to do so in a calculation problem, you're going to account for the weight of the paper in accounting for the total weight of each powder packet. So, as I said earlier, the powder packet contains at least 2 ingredients for weighing, the active ingredient and the diluent. However, in real life, to get you the total powder packet weight, and if you're told to do so in a calculation problem, you're going to account for the weight of the paper also. So that holds the powder packet together. So an example problem is here. We have a script written for penicillin powder packets. We're going to make enough for 10 days. The dose is, or the directions for use are 2.5 mg per kg per dose, orally twice daily for 10 days. The patient weighs 195 pounds. So our pharmacy has 500 milligrams of penicillin tablets on hand for you to use to crush. The average weight of a single penicillin tablet is 0.732 grams, and you need to compound packets for a total weight of 600 milligrams each. No coloring or dye will be used in this prescription, and we're going to determine the amount of each component necessary to complete the prescription. So step 1, we're going to calculate the quantity of powder packets prescribed. So we know the dose is, per dose is twice a day for 10 days. So step 1 dose BID for 10 days gives you 2 doses per day times 10 days. And I write it like that, so days cancels out in the numerator and in the denominator to give you 2 times 10, 20, leaving you with unit of doses. So 20 doses, or 20 powder packets prescribed. Step 2, we're going to calculate the quantity of powder packets needed, accounting for loss. So as I said earlier, we're going to calculate for loss 10% extra packets. So step 2, you need to do it 2 ways. 20 plus 10% of 20, or you can do 20 times 1.1, since this 1.1 accounts for 100% plus a 10% extra. So that would give you 22 packets either way. So you need to make 22 packets to account for loss. Step 3, since the directions are given in terms of mg per kg per dose, we're going to calculate the amount of AI in each packet. So we know the directions for use are 2.5 mg per kg per dose, and you know the patient weighs 195 pounds. So 2.5 mg per kg per dose. The weight is 195 pounds. So we're gonna, since this is units of kilograms, let's convert pounds to kilograms. We know that 1 kilogram is 2.2 pounds. So I write it like that. So the units cancels out in pounds in the numerator, pounds in the denominator, leaving you with kilograms. So 195 divided by 2.2 gives you 88.64 kilograms. So now we can use this 2.5 mg per kg per dose times 88.64 kilograms. Kilograms cancels out in the numerator and the denominator, leaving you with 88.64 times 2.5 to give you 221.6 mg per dose, also called packet. So 221.6 mg per of AI per pack. So step 4, we're going to calculate the amount of AI needed to complete the prescription. So we know we need 22 packets. So 221.6 mg of AI per packet times 22 packets. Let's see. Packets cancels out the numerator and denominator, give you 4875.2 milligrams of AI total. AI is penicillin. We can also from this calculate how many tablets we need. So let's see. Each tablet holds 500 milligrams of penicillin. How many tablets do we need to crush? So let's see, 500 milligrams penicillin per tablet. And we know we need a total of 4,875.2 milligrams of penicillin divided by the ratio X. So I set it up this way so you get mix of penicillin on top, and then for the ratio, and then tablets on the bottom. So solving for X gives you 4,875.2 divided by 500 gives you 9.75 tablets. But as I said earlier, you can't give a patient 0.75 tablets. That's just suspicious. So round it up. You can't. Yeah. Round it up to 10 tablets being used. And we're not gonna cut out 9.75 tablets. That's just a waste of time and resources. So we're gonna use 10 tablets to crush. So step 5, we're gonna calculate the amount of diluent, also called excipient or filler, needed to complete the prescription. So first, using the important formula, we're gonna determine the amount of crushed powder for the entire prescription. So let's see. As I said earlier, the important formula is amount of AI per tablet divided by the weight of the tablet equals part over part equals whole AI. So AI total divided by the weight of the whole crushed tablet or powder. So I know the amount of AI per tablet is 500 milligrams of penicillin per tablet. So 500 milligrams per tablet. I know the weight of the tablet up here. So the average weight of a single tablet is 0.732 grams. 0.732 grams. The total weight we need of the AI is 4,875.2. 4,875.2 milligrams divided by, we're going to solve for how much crushed powder we need. So notice that these units are in milligrams, and this one is in grams. So we need to convert. So 0.732 grams. You know, 1 gram has 1,000 milligrams. Grams cancels out numerator and the denominator to give you 732 milligrams. So let's see, 500 milligrams divided by 732 milligrams equals 4,875.2 milligrams divided by X. Solving for X gives you 7,137.3 milligrams of crushed powder. So 5B. Then, you know, given the total powder packet weight, calculate the amount of diluent needed to fill the entire prescription. So we know that the total weight of each powder packet is 600 milligrams. So each powder packet should weigh 600 milligrams. I'm gonna write it on the side since I'm running out of room. So each packet 600 milligrams. So 600 milligrams per packet. We know we need to make 22 packets to count for loss. So 600 times units cancels out, 22. Units cancels out in the numerator and the denominator. So 600 times 22 gives you 13,200 milligrams. total weight. So, drawing the picture again, if we know this is your whole powder packet. So all your powder packets, if we know all of them should weigh 13,200 milligrams total. We know the crushed powder should give you 7137.3. How much of the diluent are we going to need to fill the rest of the powder packets? So mathematically it works out as 7137.3 milligrams of crushed powder plus X to solve for the diluent gives you 13,200 milligrams total. Solving for X, so 13,200 minus 7137.3 gives you 6062.7 milligrams of the diluent. So all in all, we would need 6,062.7 milligrams of diluent, and we would need 4,875.2 milligrams of penicillin to complete the prescription. Next example, we're making doxycycline powder packets. Our farmers we're gonna make enough for a week. The SIG is 2 mg per kg per day in 2 divided doses. The patient weighs 200 pounds. Our pharmacy has 125 milligrams doxycycline tablets on hand for us to use. The average weight of 3 tablets is 0.558 grams, and you need to compound packets for a total weight of 300 milligrams each. No coloring or dye will be used in this prescription, and we're going to determine the amount of each component necessary to complete the prescription. So, like again, as example number 1, we're going to calculate the quantity of powder packets prescribed. So we know the SIG is per day in 2 divided doses. So that means we're going to use each day has 2 powder packets. So So 2 packets per day, and we're making enough for 1 week. So we know a week has 14 days, or 7 days, sorry. Ooh. My bad. Every week has 7 days. So days cancels out in the numerator and the denominator to be used 7 times 2, meaning 14 packets prescribed. So step 2, to account for loss, we need to calculate the amount of powder packets needed. So remember, we're going to account for a 10% loss. So that was step 1. Step 2, 14 packets. You do it either way again. 10% of 14, or 14 times 1.1 to give you 16, or actually 15.4. Remember, you can't give partial powder packets, so round up to make 16 packets. Always pay attention to your units and whether you need to round up or down for packets, tablets, capsules, suppositories, or just keep it as decimals. Step 3, since the directions are given in terms of mg per kg per day in 2 divided doses, we're going to calculate the amount of AI in each packet. So we know the dose is 2 mg per kg per day in 2 divided doses. 3. divided doses. We know the patient weighs 200 pounds. So we know the units should be in kilograms. So converting pounds to kilograms, 1 kilogram gives over 2.2 pounds. Pounds cancels out in the numerator and denominator, so 200 divided 2.2 gives you 400. Oh, no, sorry. Gives you 90.91 kilograms. And that's per, so yeah, he or she weighs 90.91. So using the dose, 2 mg per kg per day times 90.91 kilogram. Kilograms cancels out numerator denominator, so 90.91 times 2 gives you 181.82 mg per day. And you know the dose is in 2 divided doses, so 181.82 mg per day. You know there are 2. You know 1 day is divided into 2 packets, so 2 divided doses means 2 packets per day. A daily and 2 divided doses means 1 day has 2 packets. So days cancels out numerator denominator, so 181.82 divided by 2 gives you 90.91 mg of doxycycline per packet. So step 4, since we calculated the amount of AI in each packet, we're going to calculate the amount of each AI needed to complete the prescription. So we need 16 packets to complete the prescription. So that's step 4. Step 4 is 90.91 mg of doxycycline per packet. We know we're making 16 packets. That gives you 1454.56 milligrams of doxy. Since units cancel out, numerator denominator, packets cancel out with packets, to give you 1454.56 milligrams of doxy total needed to complete the prescription. We know that to figure out how many tablets we need to crush, we know each tablet has 125 milligrams of doxycycline. So 125 milligrams of doxycycline per tablet. You know you need 1454.56 milligrams total of doxy. So how many tablets do you need? Solving for X. Setting up the ratio where doxy's on top, tablets are on bottom. So 1456 divided by 125 gives you 11.6 tablets. But don't fool around with 0.6 of a tablet, just round up to 12 tablets. We're going to use 12 tablets. So step 5, we're going to calculate the amount of diluent needed to complete the prescription. So first, we're going to use the important formula again. And that's the amount of this is step 5. AI per tablet divided by the weight of each tablet. So part over part equals whole AI, or whole over whole. So whole AI over whole weight of the crushed powder. So we know the weight of the AI is 125 milligrams, and the average weight of 3, pay attention to this, 3 tablets is 0.558. So we know 125 milligrams of doxy. We know 3 tablets equals 558 grams. So 1 tablet dividing by 3 equals 0.186 grams. Converting grams to milligrams, since everything's in milligrams, gram has 1,000 milligrams. Grams cancels out, and the numerator and the denominator gives you 186 milligrams. So 186 milligrams per tablet. So pay attention. 3 tablets gave you 0.558. So 1 tablet gives you 186 milligrams. So each tablet is 186 milligrams. Equals 1454.56 milligrams of doxy total. Solve for X. Solving for X gives you 1454.56 times 186 divided by 125. X is 2164. 2164.4 milligrams of crushed powder. So step 5B, given the total powder packet weight, calculate the amount of diluent needed for the total prescription. So each powder packet should weigh 300 milligrams each. So if 300 milligrams each packet, we're making 16 packets. Packets cancels out, and the numerator and the denominator. 300 times 16 gives you 4,800 milligrams total mass. So we know that the whole packet should weigh 4,800 milligrams total. We know the crushed powder from the AI tablet should be 2164.4. milligrams. So how much should the diluent or the filler be to make the packet feel full and pharmaceutically elegant for the patient? So the math works out 2164.4 milligrams of the crushed powder plus the diluent, which is X, gives you a total of 4,800 milligrams. Solving for X gives you 2635.6 milligrams of diluent. So you would need a total of 2635.6 mg for diluent. And you would need a total of 2164.4 milligrams of crushed powder, which also means 1454.56 mg of doxy total. So we calculate the weight of each component needed, like the problem asked. So, as a review, key important concepts. A complete powder packet contains at least components, the active ingredient and the diluent. So use those weights and the total weight required for each powder packet to calculate the required components. For solid dosage forms, like powder packets, capsules, suppositories, you're going to account for 10% extra to account for loss. Remember this important formula. It's basically part over part equals whole over whole. Remember that partial tablets and powder packets cannot be dispensed or used, so just round up just in case anything's lost. And for pharmaceutical elements. And in real life, but we didn't do here in the calculation problems, and the weight of the powder packet should be included in reaching the total required weight of each powder packet. So account for the paper holding the powder packet together to account for the weight of the whole packet in real life, and if indicated in calculation problems. But we didn't do that here, and usually they're not required in lab. So good luck with these calculations problems and future calculation problems, and good luck with your exam, and have a good day.